Good day. You have a sheet that has a few blanks to fill in, and this video should help you do that. This is looking at one reaction, but it's going to look at it when it's catalyzed and when it's not catalyzed. So let's start with uncatalyzed so we can just talk about potential energy diagram. Right here we have the energy of the reactants. And the reactants are O3 and O. Then here we have the energy of the products. And we can see that our products are going to be two O2s. So what happens is the forward reaction has to clear this hurdle, has to have enough energy. So this 17.1 kilojoules is the activation energy for the reaction. And then it spills into the products. So this is an exothermic reaction because the products have less energy and reactants. And we can see the forward reaction should be faster than the reverse reaction because the reverse reaction has a bigger activation energy. Right here would be the activated complex. It would have a total energy measured from the bottom, the baseline, but the activation energy is the difference between the energy of the activated complex and the reactants right there. Now, if we had a catalyst, and earlier we've said a catalyst is a chemical that speeds up a reaction but is not used up. Sometimes it speeds up by providing a surface. But here's another thing we notice about a catalyst. A catalyst gives a different pathway, and the different pathway has a lower activation energy. So we don't have as big a hurdle. So what we see is if chlorine is our catalyst, all of a sudden we have to clear one hurdle, clear a second shorter hurdle, and we make the products. But both hurdles are way smaller than this. Well, what does that mean? Why is it faster? Well, it simply means more particles are likely to have this amount of energy to clear the hurdle than this amount, which might be 3 times as much or 3 times what that activation energy was. And another way to think of it is we've lowered the bar. If we asked the school to do a high jump, all the members of school to do a high jump, there would probably be maybe 10 people who could jump 5 feet, clear a 5-foot height. But if we drop that bar down to 3 feet, we're probably going to have close to 300 people who could clear that hurdle. And that's what we've done. You lower the hurdle, you make it easier for the particles to get over the hurdle and make the products. So that's what that diagram is largely about. So let's fill this in. Uncatalyzed reaction is a higher activation energy. That means fewer particles have enough energy to make the activated complex. So the case is the reaction rate is slower or lower, and we get a slower reaction. For a catalyzed reaction, we've lowered the hurdle so more particles can clear the hurdle. If more particles can clear the hurdle, we get a higher reaction rate. A faster reaction is going to take less time. So the role of a catalyst is to provide an alternate pathway with a lower activation energy. And then we get to the main definition, speeds up the reaction without being consumed. So it's involved, but we get it back at the end of the reaction. So this is a very important set of notes, gives you a good sense of PE diagrams.